All right, this video is going to go over some review problems. It's going to cover complete graphs, proportional reasoning, and writing equations. All right, so our first problem says we want to make a complete graph for this equation, y equals negative x plus 2. So before we can make a complete graph, we need to make an xy table, and we need to pick some x values. So I always choose a couple negatives, a couple positives, and 0. So I'm going to do negative 2, negative 1, 0, 1, and 2. All right, so now we are going to plug these numbers here in for x. So I'll start with negative 2. So right here, I need to plug in a negative 2 there. Well, it says negative right here, and then it says x is negative 2 plus 2. Well, I have to think, what's the opposite of negative 2? Which would be plus 2 is 4. All right, let's go ahead and plug in our next one. So we have a negative 1, so I'm going to plug in, it says negative already, and then it says negative 1 plus 2. Okay, now I'm going to do the opposite of negative 1, which is positive 1 plus 2 is 3. All right, let's plug in a 0. All right, if we plug in a 0, we just have 0 plus 2, which is 2. That one's pretty easy. Okay, let's plug in a 1. If I plug in a 1, it says negative and then 1 plus 2, which gives me 1. And if I plug in a 2, it says negative, plug in that 2 plus 2, which is 0. All right, now that we have our points, we're going to make a complete graph. So first thing that you need to do is put your x and y, label your x and y axis, and then let's go ahead and start plotting the points. So our first point is negative 2, 4. So I'm going to go over negative 2, up 4, put my first point. My second one is negative 1, 3. So I'm going to go over negative 1, up 3, and put my next point, which would be right there. My next point is 0, 2, so I'm going over 0, up 2. So that's going to be my y-intercept there. My next point is 1, 1, so I'm going to go over 1, up 1. And my last point is over 2, up 0. Okay, now to make it a complete graph, first thing I'm going to do is connect it, draw arrows on the end of my line. Okay, now you need a couple more things to make it a complete graph. We need to label any special points. Well, here's one special point, the y-intercept. So the coordinates are 0, 2. There's another special point, it's the x-intercept, which is actually 2, 0. Okay, so I labeled my special points, and then the last thing is I need to write my equation on the graph. So my equation was y equals negative x plus 2. Okay, you can also label what you're counting by. So I'll just put my 0 here. I'm just counting by 1, so I'll just put 1, negative 1, negative 1, 1. Okay, so I'm counting by 1, so I just labeled it a couple places. So again, if you're counting by 1s, you don't always have to label it, but you can as well. All right, so here's our next problem. We want to know, is this proportional or not? So to test if a table is proportional, it has to be changing by the same amount each time. So I have to figure out, well, like, how do I get from 3 to 4.5, from 7 to 10.5? Am I multiplying by the same rate? Is it changing by a constant rate? Well, to figure that out, what you can do is you can take either the x divided by the y, you can do that, or you can do the y divided by the x, and you should get the same number each time. So I'm going to take the y divided by the x. So I'm going to type in on my calculator. If you have one, you should grab it. I'm going to do 4.5 divided by 3. When I do that, I get 1.5. Now, that should be the same for every single one of these if it's proportional. So now I'm going to do the 10.5 divided by 7. So I'm going to type that in, and I get 1.5 again. Okay, then I should test out the 30 divided by 20. I should test out all three of these. So why don't you test those out and see if you get 1.5 for each of them. All right, I do get 1.5 for all three of those. So it is proportional. Okay, it was changing by that same constant, or 1.5 each time. If I didn't get that 1.5 each time, then it would not be proportional. All right, here's another proportional reasoning problem. It says Juan, he jumped 6 times in 4 minutes. At that same rate, how many jumps could he do in 18 minutes? Okay, so right away when it says at that same rate, we know it's going to be proportional. It's changing by the same amount every single time. We also know that if John jumped for 0 minutes, he would jump 0 times. Okay, so it also goes through the origin. So we know we can set up a proportion. Okay, so I'm going to kind of write down what I know. He jumped 6 times in 4 minutes. I'm just going to put a little m by the 4, so I know that was the minutes. I'll just put a little j by the 6, so I know that was the jumps. Okay, then it says at that same rate, how many jumps can he do in 18 minutes? Well, that 18 minutes needs to go across from the 4 minutes, so I'll put my 18 minutes right here. And I don't know how many jumps, so I'll put an X there. Okay, so now we learned that you can cross multiply and divide to solve this. So I'm going to do 6 times 18. So grab your calculator, type that in. And you get 108 equals, you can do 4 times x, which is 4x, and then your last step, divide by 4. So 108 divided by 4 gives me 27. So he can do 27 jumps in 18 minutes. All right, our last problem says write the rule for this table. So we know it's going to be y equals something. All right, in chapter 4, when we learned about this, we learned that if you ever are given the 0, you know that's kind of a little hint. That's going to be this part here at the end. So I know it's going to be subtracting 2. I just have to figure out, well, what am I timesing the x value by? Okay, so you can do some guessing and checking. I usually start with times 2. So I'm just going to test that out. So I'm going to do, let's just try negative 2 times 2, which is negative 4 minus 2 is only negative 6. So that does not work. Okay, timesing 2 doesn't work. Let's try timesing 3. So if I do negative 2 times 3, I get negative 6 minus 2 more. That does give me negative 8. Now I should always test that in a couple of the other ones. So I'm going to try it with the 4. Let's see, 4 times 3 is 12. Take away 2 does give me 10. That works. Try it back here. 3 times 3 is 9. Take away 2, that is 7. So that works. So my rule would be I'm timesing the x by 3, so 3x, and then I'm subtracting 2. There's our rule.